Welcome to Wagner Academy. This is Geometry 4.3. We're talking about congruent triangles in this lesson. Some new terminology. Make sure you understand these things by the time we're done. And make sure you use those extra examples in your book, as always, to help you with any assignments you might have. Triangles that have the same size and shape. That's what goes in these first two blanks. Triangles that have the same size and shape are called congruent triangles. So that's what congruent triangles are. They're triangles that have the same size and the same shape. We talked about congruent things before, especially with segments. Congruent segments had the same length. Now we're talking about two-dimensional figures instead of a one-dimensional figure like a segment, so they're going to have the same size and shape. Any triangle has, three angles and three sides. So if that's the case, all six corresponding parts have to match up. So this should say if all six corresponding parts in two triangles are congruent, then the triangles are congruent. That's how we know if triangles are actually congruent. So all six parts have to match up. So in example one, suppose the triangles below are congruent. So we're going to assume that they actually are congruent to start. We don't have to prove that in this one. Identify the congruent triangles using an appropriate congruence statement. Oh, and that's such a happy looking little girl there. So it looks like we have triangle HPY, kind of for happy, and then girl GRL. We got that triangle as well. So on this one, we can assume they're congruent. That means parts are going to match up that look like they match up. Can we assume that otherwise if we're not told they're congruent? No, but we can assume that here since we are told that they are congruent. So I'm going to say that this one and this one match up. That's, I think, pretty clear looking at the picture that those would be the two that would have to match up. This one and this one, I use a different number of tick marks for that, and then put 3 here and 3 here. And then I'm going to have 1 here, 1 arc mark on G, that has to match up with P. I'm going to put 2 on H, that's matching up with R. And I'll put 3 on L and 3 on Y. Those two angles are also matching up. So a congruent statement, that's a fancy way to say, write that the two triangles are congruent to each other. Make sure you put them in proper order. So triangle HPY is congruent to, and here's a mistake I see quite often. I did this on purpose. I was trying to bait you into the wrong answer. Oh, it's such a happy little girl. HPY happy is going to be congruent to GRL girl. No, it's not. Hold on, hold the phone. Don't go anywhere. HPY, that would match up in the same order over here as R, G, and L. You have to have the corresponding letters matching up. So if you said GRL, that's not correct. And this one you have to say HPY. If you're going to put them in that order first on this triangle, they have to match up in that same way on the second triangle. So R, G, L would be a valid way to say that. So to remind us of this, use a different color for this if you have one. This one matches with this one. P, I'll put 2 underlines under that, matches with G. And finally Y matches with L. And that corresponds with what we have up here. And so I can box this in now. That's my final answer. This is my congruence statement. So I'll write that off to the side over here. This is a congruence statement. If they ask you to identify congruent triangles, we have to write a correct congruent statement. So something like this. So let's make a little note. I'll use my different color for this, that the corresponding, and I'm making a note about this because it's a common mistake I see. Don't just assume that the letters are spelled in the proper order. If they're spelling out words, something like that, make sure they actually match up in the way that they should. So the corresponding vertices must match the picture. So important, it deserves an exclamation point. There it is. Okay, so moving on from a happy girl to an angry little boy right there. We'll check that out in example 2. However, before that, two triangles are congruent if and only if their corresponding parts are congruent. So this is an if and only if statement. That means you can start by saying two triangles are congruent, and that means the corresponding parts are congruent. You can start by saying the corresponding parts are congruent, and that also means the two triangles would be congruent. So it works in both directions when you have that if and only if phrase. And CP, this is an acronym we'll use quite often. CP, CTC, stands for corresponding parts of congruent triangles are congruent. So did you see where those letters come from? I hope so. You've got the C, P, C, T, C. I've also heard it called C, POC, TAC. So I'd be fine with that if you wanted to call it. That's including the O and the A. But CP, CTC, that's what our book will have. That's what most books will say if they're going to abbreviate that. So this is an important justification or reason for a lot of things that we'll be talking about as we move on with triangles. So example 2, show that the triangles below must be congruent based on the definition of triangle congruence. And that again said that all 6 parts had to match up. So we're going to name the corresponding congruent angles and sides, and then name the congruent triangles. So when we name the congruent triangles, it's got to be like this. The corresponding parts have to match up. So let's start with the sides. And let's see what we got. So it's saying that these must be congruent, but we have to actually show how this time. We can't just assume that they are. We have to basically prove that they are. So the sides, well, I've got this side and this side matching up. I've got this one and this one matching up, and this one and this one. So they kind of gave me all the sides already. I just need to write out what matches up with what and how that works out. So AG, segment AG would be congruent to segment OB. I could say BO, but that's gross. So segment OB, and this is, as a reason, that would be given. I'm told that in the picture. I'm given that information in the picture. GY, segment GY is congruent to segment BY. That's also given in the picture. They both have the same number of tick marks on them. And finally, AY and OY. Those are also congruent. And then for the angles, oh man, I got nothing. I got nothing about the angles. However, I do have this right here. I've got this side parallel to this side. So I can use some things I learned back, and we learned back in, I think that was chapter 3, and we can prove some things about these triangles. So this was coming from lesson 3.2. We have parallel lines here. Here's a transversal that cuts through these two parallel lines, these two parallel segments at least. We can say then that this angle A, matches up with angle O. We can also say that angle G matches up with angle B based on that. So I've got, for the same reasons here and here, this transversal and this transversal with respect to these two parallel lines. These are alternate interior angles, here, 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 and here. So I can say that for the angles, angle A is congruent to angle O, and that's AIA, alternate interior angles. I can say that angle G is congruent to angle B, also alternate interior angles. And then we got to have all 6 parts, so we're missing this angle, but these two, very nice, are vertical angles. So I can say that this one would also be congruent to this one. So I can't just use one letter here. Before it was obvious, it was clear that A could only represent this angle. Now I got to use 3, so I could say AYG, that would be this angle right here, is congruent to OYB. And that would be by vertical angles. So we've proven all 6 parts are congruent. That means, by the definition of triangle congruence, that the triangles themselves are congruent. So now we can say therefore triangle, and got to put them in a matching order, so I'm going to go with AGY. If I go in that order for the first triangle, it has to be in this order for the second triangle. I went 1 arc mark to 2 arc marks to 3. Got to keep that same order going, 1 to 2 to 3. So I could say OBY. Time for now our next slide. I was going to say our next example, but that's in the last slide. So for some properties of triangle congruence. This one is the reflexive property. This one is the symmetric property of triangle congruence, and this one is the transitive property of triangle congruence. And these properties are first discussed in terms of segments and angles in chapter 2, in the latter parts of chapter 2, but the same properties here apply to triangle congruence. So the reflexive property says that it's basically a reflexive thing. Like you think of reflexes, it's something that's automatic. This is automatic. I think it's very obvious, but sometimes it's a property we actually use to prove things. So triangle ABC is congruent to, get ready to have your mind totally blown, triangle ABC. It's congruent to itself. Right here is the statement, and we could say, I'm going to draw some things up here in the pictures with a different color. This is triangle 1, and this is the same triangle, triangle 1. Wow, okay. This is congruent to itself. Makes sense? I hope so. So triangle 1 is congruent to triangle 1. I'll leave the circle off there. All right, so triangle 1 congruent to triangle 1. Now keep it down there. You decide what you want to do, but you can take your pick. I'll circle it. So symmetric property of triangle congruence states that if, I'm going to write a little smaller on this one, I'm going to need 2 lines here. If triangle ABC is congruent to triangle DEF, then triangle, it works in the opposite order. So it's kind of like symmetry. Looking in a mirror, you have symmetry there. So yourself looking in the mirror is the same as the mirror looking at yourself. Ooh, mine's getting blown again. All right, so if triangle ABC is congruent to another triangle, DEF, then that other triangle is congruent to the one you started with. And up here in the picture, I'll designate that with a 1 and a 2 now. We have a second triangle, but this works in both directions. So if 1 is congruent to 2, that means it works going this way or this way with the symmetric property. You can say 1 is congruent to 2 or 2 is congruent to 1. And then the transitive property says that if you have, well, I'll do this with the colors first. If you have a first triangle, a second triangle, and a third triangle, and you have the first one congruent to the second, and the second one's congruent to the third, you can skip that second one. You can go all the way from 1 and say that 1 is congruent to 3. You can eliminate the middleman, kind of the middle triangle. So in a sentence format, you could say something like this. And again, write a little smaller on this one. Triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to, have to skip down to the next line, it's congruent to triangle GHI. Then the first one, ABC, is congruent to the last one, GHI. So that's the gist of those 3 things. So we may be using these ideas later to prove things about triangles, or that one triangle is congruent to another. And the final idea, the new idea in this lesson, is this. If you slide, flip, or turn a triangle, the size and shape do not change. These 3 transformations, I should say transformations, not transformation. Let me fix that real quick. I'll make sure that's fixed on the notes that you have. So these three transformations are consequently called congruence transformations, because congruence still holds from one to the next. So the types of triangle, or the types of congruence transformations with triangles here in this case, but this works with any polygons actually. You can slide, or another word for that, I'm going to have you write that off to the left because you might hear this called translate instead. Slide or translate. We'll learn more about slides, translations in a later chapter. We haven't learned about it yet. Turn or rotation is another name for that. And then this one, a flip, is also called a reflection. So a flip or reflection is what we have in this last box. So a slide, you just do exactly what it sounds like. You slide it. You just move it, but you don't turn it at all. You don't flip or rotate it at all. And so let's just write that with, I'll use a different color for this. This is just sliding down to there. This one is rotating, or it's turning in this direction. I'll go with red here. It's okay if you use the other color, but I'll do all this stuff in red. So we are rotating, we're spinning it around a certain point. So to show you that I'm not just messing with you here, that this one is actually the same as that one, I'm going to just undo this right after I do that. But notice I just turned it like this, and then I moved it over here just so the one wasn't right on top of the other. But these two triangles are the same. You can tell that after I turn it a little bit, that they are actually the same size and shape. And then this one, I flipped it or reflected it. So if I do this, my program's pretty fancy here. It can mirror stuff in the X and Y axis. So if I flip that, oh, now it looks the same as that one. So I actually started with this one, I flipped it over here and got back, or I got a congruent triangle that I just had basically picked up, flipped over, and set back down a little bit away from that. So on this one, you have a flip or reflection, and this is right about here. This is the line that you'd be flipping it over, reflecting it over. So this is a, like that, a flip. So this one we turned, this one we flipped over this line. And now finally the last example. So on this one, verify that the triangles are congruent using a protractor to measure any angles, okay? And then name the congruence transformation. So is this going to be a slide, a turn, or a flip? Did I maybe give you a hint here? Maybe I'm trying to throw you off. This looks like a slide, but does this look like a slide to you? Does it look like I just basically picked this up and slid it up in this direction? Yeah, I would say so. So I'm not trying to trick you here. This is going to be a slide or a translation rather than a rotation or a reflection. But let's do what it says here. So verify the triangles are congruent. To do that, we have to show that all the angles are the same and all the sides are the same. So just because they look like it doesn't mean that they actually are. We have to actually prove it beyond a shadow of a doubt based on the information that we can see here in the picture. So I would start with this one with angle D and D prime. This is clearly going to be a 90-degree angle. You have a horizontal portion and a vertical portion. That means that would have to be the case right here. I'll use my different color for that. So I know that has to be a right angle, that has to be a right angle. I don't have to use a protractor to show that that's true. So the measure of angle D equals the measure of angle D prime, which equals 90 degrees. So that is one step. We've proven 1 out of 6 things there. I still need to have 5 more. So measure of angle S, why don't I go with that next? This, if I use my protractor like it says I can do on this one, there you are, protractor, and I will shrink this down as much as I can here. If I place that on the dot there, right there, I'm trying to, it's jumping around a little bit, but yeah, that looks good right there. So I line that up, and it looks like it's right there. And I had measured this myself on my own paper. It looks like it was at 27 degrees, so that's a little small. You might not be able to see that there, but if you use a protractor, you can verify that for yourself. That's at 27 degrees. I will close that. So this is the same thing. If you put it on S and measure it again, you'll get the same thing. I'm just going to save us some time here in the video and let you know that I already did that before. So I verified both those, but good little protractor practice there. That's step 2 of 6. We've shown that those are the same. And for L and L prime, we could measure those as well, but I can also remember the triangle sum theorem states that they're going to add to 180, and so if both of these are adding to 117, the third angle theorem tells me that the third angles are going to match up as well, and that angle measurement would be 180 minus these two added together, leaving me with 63 degrees. So that's step 3. And again, you could put your protractor on angle L and angle L prime as well and find that they are matching up with that as well, or in that case. The sides. Alright, the sides, SD and S prime D prime, very easy. LD, L prime, D prime, very easy. Why do you say that, Mr. Wagner? Well, just count the jumps. This one's horizontal, this one's vertical. We don't need to use distance formula, Pythagorean theorem, anything like that on that one. So SD is S prime, D prime. Remember, if you don't write anything above it, that means the distance from those points, or from that point to that point. And so this would be 4. I see that that's 4 there. It's a jump of 4. So that's step 4. Step 5, part 5, we could say LD equals L prime, D prime. And both of those things are equal to 2. So there's 5. We're almost there. We need one more. 6 parts, all 3 angles, all 3 sides. On this one, you could use the Pythagorean theorem, or you could use the distance formula. I haven't used the distance formula in a while, so I'm going to use that here. If you wanted to use the Pythagorean theorem instead to figure out the length of SL, go right ahead and do that and see that you get the same answer. Nothing wrong with that, but I'm going to label these. This is a -6, that's 1, not 0, -6, 1. And this one is -2, 3. S prime is 1, 3, and L prime is 5, 5. So just a little practice with the distance formula here. And again, if you want to use Pythagorean theorem instead, be my guest. And so we'll have, I'm going to go with green on this one just to make it a little more clear. So I'll call that my red x1, y1, red x2, y2, and then my green x1, y1, my green x2, y2. So as I go through that here, I would have that SL is going to equal the square root of the difference in the y's squared. So y2 minus y1 becomes that. And I've got that plus the difference in my x's squared, -2 minus -6. And squaring that. So I take the square root of that whole thing. That leaves me with 2 squared plus -2. This will become plus 6. -2 plus 6 is positive 4. So I have positive 4 squared. 2 squared is 4. 4 squared is 16. Add them together. You've got 20 under the square root. And then in green, so that's this one right here. And why don't I quickly highlight that to show what I mean. So that was this one right here in red. And then this one I'm going to do in green. Right here. So now I'm finding the length of that segment. So this is S prime, L prime. I feel like it's kind of hard to see that. There, so let's go with that instead. So this was matching up with this part. This is matching up with this part. S prime, L prime is going to equal difference in my y squared, so that's y2 minus y1, 5 minus 3 squared, plus the difference in my x's squared, 5 minus 1 squared. And that, would you look at that, it's the same thing, 2 squared plus 4 squared. And that's what we expected, because we thought that they appeared congruent, and now we've shown that they actually are congruent. So these are the same. This is step 6 right here. Since I used red and green for those, I'll do this in blue. This was step 6. So all the steps, they all checked out. It all worked out in the end. So we've proven all 6 corresponding parts are congruent. So let's write that down. Since all 6 corresponding parts are congruent, the triangles are congruent. And therefore, I can make that congruent statement now. I know that triangle SLD is congruent to triangle S prime L prime D prime. And what kind of transformation is this? Let's answer that final question. So name the congruence transformation. That is a horrible box, but just go with it. So what kind of transformation was this again? This was a slide. This is just basically picking this up and sliding it on up to there. And it is, so let's just write, it's a slide. You can write that next to it. And that'll do it for this lesson. Make sure you review those as needed. Review the video as needed. Make sure you understand these things now that we're done. We should understand what all these different things are and how to apply them and be able to define them. Make sure you have a great day, and I'll see you later for our next lesson. It looks like we got 4.4 coming up next.